Hey everyone, welcome to this Python tutorial. In today's video, we are diving deep into how Python works behind the scenes. Let's first start with the Python definition. Well, Python is a high-level, interpreted, dynamically typed, and somewhat strongly typed general-purpose programming language. It's known for its simplicity, readability, and versatility. Yeah, that's about the Python definition, and we know that no one is going to ask what is Python, but they might ask what is a high-level language, what is an interpreter, what is an dynamically typed, and what is strongly typed. So these questions they might ask. So we are going to learn these topics in today's tutorial, and also we are going to learn about JIT and PVM. So coming to let's start with the high-level language. So high-level language, it's the language that is in the human readable form. So the code that we write, like in Python, C, and C++, they consider to be human readable form because, yeah, programmer actually with some practice, programmer can understand them. So they are in the human readable form, and but they are not in the form that machine can understand. So we need to convert them into machine level code. And so this was the high level language. So what is the low level language? The low level language is like machine code. So languages are machine code and assembly code. So these are the languages that machine can understand. Assembler assembly language, it's is not fully understandable by the computer. We need to convert into machine level code. For that we use assembler to convert it into machine level code. Machine level code is nothing but zeros and ones, so the form computer can understand. So coming to assembler, I've told you that it's somewhat difficult to understand by the humans. Like add AX5, so it's somewhat we can understand, like add, it's an add operator. But if there is a machine large machine assembly code we need to write, it's very difficult to write. It's very difficult to remember every syntax of this, and it's also not easy for the machine to understand. So for that but it's the advantage of this is that when it can be converted into machine code very fast. Yeah. So coming to assembler is the category that belongs to like interpreter and compiler. So what are all these? So let's start one by one. Let's start with the compiler. Compiler we use in the C language or C++. Okay, when we convert this code into machine level code, this time of converting from high level code to machine level code is very fast. In the compiler, what we actually do, we first convert this high level code to assembly language, and then this assembly language is converted to machine code using the assembler. And this process is faster than interpreter. So what is an interpreter? So interpreter, in this we convert we convert our high level code into machine code line by line. Okay, but this is not exactly true. We are not converting directly the high level code. We first convert the high level code into bytecode. Its .pyc file is generated, and this bytecode instructions are then converted line by line into machine code. The bytecode that is generated, it's a platform independent code. Okay, so let's understand why by an example. So let's assume this is the code. We have written a simple code to add A and B. So we can add, we can pass the values and we can add them. So the bytecode we can found in the pycache folder .pyc file. It's a platform independent. This line is very important. It's a platform independent, so we can use bytecode in any operating system, Linux OS, Mac OS. We can just transfer this code into any operating system, and then then from there we can just directly run the code. Now this code we will convert it into bytecode. So bytecode is not easily understandable, but for our understanding, we can I have converted using the Python that bytecode into instructions. So these are the instructions. So it is these are the memory of set 0 2 4 6. These are the memory of set. So first we are saying load fast 0 0 at the 0th index it was A. So load fast 0, load fast A, load fast B, then binary add, then we are doing binary add, then what we are doing, we are returning the value. So these are the instruction that will be passed to Python virtual machine. So coming to Python virtual machine, what is a Python virtual machine? Well, this is the machine. This is the thing that we use after converting to bytecode. This machine, what it do? It runs the bytecode line by line at the runtime only. So there will be no machine code file will be generated, and in the compiler there always a machine there are always a machine code is generated, but here the machine code is not generated. We just read the bytecode line by line and we convert it into machine code, and we get the result what we run the program, right? So this is why this is why Python is slower than compiled language like C, but more flexible and platform independent. Yeah, it's we have seen that it's platform independent. Yeah, but it is slower because bytecode and we converting into machine code. And why it is slower? There is one issue, like we are converting into bytecode and we are running line by line, right? So in this case, if any function which is very frequently used function, so we are not using directly the machine code. We know that this function is going to be frequently used, so we should have the machine code and we should directly run that, right? Compiler do that, but here we don't do this. That's why Python is a little bit slower. Yeah, it at the slower side, but we can use just in time compilation with it, like we use in the Java, to make it faster. So in what just in time do, the cons was that frequently used functions, we cannot directly use their machine code, but in the git we can directly use their machine code for the frequently used functions. This improves the Python performance without changing the bytecode. Yeah, but they are still not as fast as the compilers. Java is not faster than C, right? So coming to dynamically typed and strongly typed in Python, what are dynamically typed? So dynamically typed is when we have defined a variable like x is equal to 5, x is equal to 5. So when we have defined this variable, we have not defined the data type. In other programming languages, we define int x is equal to 5, but here we have not defined. From the value, it will interpret that it's an integer, right? And will similarly x is equal to a string hello. So it's a string, it will understand from the value. We have not defined the data type. And we in the Python, one more thing what we can do x equal to 5, and then for the same variable we can assign a string. So this is we can only do in Python this type of thing. That's the for the same variable we have for the same variable which was int before, we have assigned it to a string. Yeah. So now coming to strongly typed, if we will try to add this, like a is a integer, b is a string. If we try to add those, it will not give the error. Without running the code, it will not show the error. That's why I said somewhat strongly typed. Strongly typed means like without running the code on the ID only, you will get the error that this is the problem. But this you will not get the problem until you will not run this code. When you run this code, you will get the error. But yes, I said somewhat strongly typed. It's still strongly typed. Like I have not given the indentation, and in the compiler only it is telling that there is a problem with it, and you have not given the indentation here, and indentation is expected. So in this way, so this is what we this is why we call it somewhat strongly typed. And the pure strongly typed language is the C sharp. C sharp is a pure strongly typed language in which if a plus b is defined, it will show on the ID only that this is wrong. And JavaScript is and coming to JavaScript, which is not a strongly typed language, not a strongly typed, it's not somewhat also, it's not partially strongly typed also. We will write the Java code, ID will never show the error until you will run the code, it will no the error will not be shown. Yeah, thank you for watching the video. Until next time, may your code run bug free and your commits be clean. Thank you.